Hey. Okay. Let me load the chat. Okay. So let's go back to the code. So I fixed the code, but before continuing, I want to show you uh, platformer, create set explorer. No, it's not what I want. Let me see. Okay, we're back. Very good. Okay, so I created, so this is the GitHub page that is updating with everything, every change that I make. It's a platform grid. This is the repository. And under, there is a Leasy repository that there are all the projects that I make for Leasy. I will sometimes, like, if they don't have their own direct repository, or if they are small code, I don't have to make a repository for them. Or sometimes these codes are the codes that I have to put them like step by step. Every step that I do things, I just update them. I put everything under Leasy. And then here there are different projects, like from past projects. There's the Rust game that I made, and then there are Zig projects here. There's the Snake, and then there's also the platformer that I'm doing. And the first step was to include platforms. The second step is to include player, like all the projects are in here. Oh, sorry, I just didn't update Discord. Let me send a message to Discord. But yeah, you can come to these pages and see the steps that are being made. Yeah. And all of these links are in the description, so you won't have any problem there. Okay, so let me first. Okay. announcements. Okay, YouTube is your channel. Get the link for the video. And I just put it in announcement in the Discord server. Okay. And if you want to have access to the Discord server, the link is in description. You can join there. We can discuss like anything as you want in general. I mean, if you want to talk about the stream or like your experience in different programming languages and stuff, if you want to give some ideas and feedback, everything is in Discord. In general, there's some space that you can use. Let's go back to the code. So okay, what's the first thing that I want to do now? The first thing that I want to do is that, so let me first run this. So let me see if you see what's on the screen. Yeah, okay, very good. So we have kind of platforms here and there. These gray ones are platforms. Background color is not completely black, but it's okay, I guess, for now. And the blue thing is our character. First, we want to be able to move this character, and then yeah, I want to have some bigger platforms to be able to start the ray casting and vision. And then from there, we will have to add shaders for the vision and stuff. So there is a lot of fun uh, waiting for us, or at least for me, but I hope for you too. And by the way, music for stream is now okay. I can just play it, but I don't know about the sound volume. So if there is anybody in the chat that is live now, they can help me out with this, because I don't have a playback on a different system. I cannot really see how loud the music is. But if you're here, you can just let me know, and then we can fix the like how loud the music is, so that I can play it from now on in this stream. Okay, let's go back to the code. So the first thing is that through many changes that I tried to make and a lot of AI suggestions, some of the lines were deleted and removed. Some of these lines were supposed to help with the player movement, and they're in the event loop. So, or event switch. Just don't find them anymore. Let me. Oh yeah, here. Handle events. Okay. So on, I think it's key press. Okay, I'm gonna put the const speed equal to 0.02. Okay, so what it does, it just checks if the key press is one of these keys, like up, down, right, left, and changes the, okay, not the position, we want velocity. Yep. And then it shouldn't be plus or minus, it should be equal to this. So on left we reduce from x, on top we reduce from x. Yeah, that's it. And I want to revert all these changes when the key is released. Okay, this should work. Now in update, update system, here the first thing we want to do is we want to app.player.shape.position plus equal to velocity. Okay, that should work. Okay, let's run. Okay, so the velocity seems good. The up down is kind of opposite. I think they have to be, yeah, multiplied by -1. And then I can make the platforms also a little bit bigger and nicer. So, and even add more. How do we do? Okay, so I will add a constant named, oops, well, maybe it shouldn't be here, it should be probably in types. In the platform area, map area, I will add public constant plat number. And I will put it equal to 4. 4 is not, I mean, I can't just add more platforms, no? 8 platforms. I mean, maybe 4 is okay for now. And then we go here in the map. Sorry, in Here there is, okay, I think it's in setup pipeline, right? Where do I do? Okay, here. It should be map area Vietnam. Declared identifier map area t.map area platform number. Well, that's okay. Now I need to fix the movement, handle events here. Okay, up should be, oh, okay, it's the opposite in WebGPU to what I used to do in Raylib. So down is negative and up is positive. Yeah, it's now working. I'm going up, I'll go down now. Okay, very good. Okay, let's try to make these platforms a bit bigger, and I guess these are two platforms just very close to each other. I can make them some space. Where do I define platforms? It's in the map. And then I do, these are shaders. I'm not gonna work with shaders for some time, so I can just for my own insanity, I have to make them in multiple lines. Okay, I can just close these two and then go here in the types. Oops, I think I closed wrong. Types here, I want to be able to change, yeah, here. Okay, this could be 5, 0, it could be 0.5, and then size could be 3, 2, x is 0, y is minus, okay, and here 0.5. Here 0.3. So it should look more clear now, the platforms. Okay. Now I want to do what I want to do is to be able to do raycasting vision. Okay, how do we do that now? So in my previous project, what I did was that I considered these platforms. I had some radius vision, and I would consider a square uh, by the size of this vision. Okay, I can define vision here, vision radius of 32, and I'm gonna put it equal to 200. Okay, that's like, oh, but 200 is not the same measurement as we have here. I would have to go 0.4, I guess. Okay, I don't know. I will see how much is it, 0.4. And then, yeah, that should be okay for now. So we have vision radius, and now we want to be able to see what platforms are in this vision radius, and only um, yeah, and then draw rays to these platforms as we did. So there are multiple ways to go around this. I can try to clip the platforms that are inside the vision square. Um, should I go on with the platform idea? I think it would be safer if I just try with the walls and segments, right? Because or okay, now hmm. um how do we proceed this thing? I think I'm not gonna pollute this file. I'm gonna make another file specifically for um, revision, and then I want to use the bounding volume hierarchy. So it's an algorithm that helps me to reduce all of this, um, like we can use it for collision checking and for vision checking inside some of these. Yeah, we can do collision checking and ray collision checking with the bounding volume hierarchy. Is I mean, it's faster, and it's kind of a binary tree. So okay, I need to implement that. So first thing I want to do, should I put them in type, or because these are related to this, so I'm gonna use the system for other things like for collision and stuff. So I'm gonna put this in the types in here. Okay, so the first thing I want to do is to create PHP struct. Okay, and it's not extern because I'm not gonna pass it to GPU. Okay, and this thing is the root. No, it has the functionality of all the things that I need. So it should have a root node. Okay, it should have a root node, and then I can actually make this a different file. PHP zig, BVH zig. So this is BVH const cd port cd. Okay. So I'm gonna put it separately, and then I will see if it's small enough. I can just fit it in some other places. Okay. So what we want, we have some root nodes, and then we have some leaf nodes. Leaf nodes are our platforms, and root nodes are containers of other nodes. Or it could be branch root nodes, and then there's leaf nodes. Sorry, we have root node, and then it's so. Should I go with a union, or I mean, we can do this one, right? Tree node. It's a structure where we have child right, child left, and then we have AABB. And our AABB is just a rectangle. Const t equal to import types. Let's see. And this is just t.rect. Okay. think this should be okay, no? And then this is some kind of a tree node, and we will have a root which is a nullable tree node. And then okay, and then here here in my rectangle, I need a function that returns of an center rectangle. It just returns a vector, not a vector, it's a vector. It's the position plus size divided by 2. Yeah. Okay. Okay. Yeah, for now this is enough. Let's try start. So how do we do this? I need a function to add nodes. Add node fn add node, and then here I have vh and of course let me do this constant is it this? Okay, then we don't have to do this. And then this is not a node, this is add AADV add rect. Okay, there is this tangle, and then pub fn init vh. I will need a allocator. We try. I will make indicator, and then here I have to say EVH dot star is equal to this. Okay, and then I will return the pointer. So that should do it. And then here the rectangle. Now, so to add a rectangle, we have to first look for, okay, I don't remember actually what was the algorithm for binary tree. So if I want to insert, so this is insert, I will just change this to insert rectangle because it's just, okay, so if we want to insert, we first search for location and then insert this rectangle in the location that is needed. To do that, we get the center. Okay, we get the center. No, variable parent evh.root, and then we get const center is the center of rectangle, and then okay, bvh.root is equal to null. Root try tree node.create. What is this? Kill but insert done. Does this work even? I don't even know if this type of coding work in Zig though. So I don't remember how am I supposed to do this? So we have a parent. We have to first check if this parent is null. And we can do that by just doing this. If parent node, and then if it's not null, we kind of do this one. We call on node dot insert rect right, and if it is null, then it's not a variable, right? Oh no, it is. Now I have to say parent equal to try. I need allocator here, by the way. I don't know what's the best solution here. Should I pass it in each insert rect, or should I put it here? I think I should just put it here for now. Allocator, and then here, yeah, allocator, and then here try bvh.allocator create tree node. Okay, child left, right, AABB is rect. This is not needed. It's the same pointer, right? Is it? I'm not sure. I don't even remember. So there is something wrong about this code. Okay, how do I use center, by the way? Oh yeah, okay. Here, so if this node is not null, I have to check if the child or left or right are defined, if node dot child right, that's right, and then but we have to do this later. We have to first see, okay, okay, here is node dot size 0 is less than node dot size 1, we have to cut it in half. But this is when we are creating, right? Okay, why is this so complicated for me? Okay, the center, if center 0 is less than, what is, okay, this rectangle has a center, and this node has some kind of a division, and then this division is either horizontal or vertical, right? Separation, it's a struct or enum. Separation equal to true. Okay, separation is false for vertical, and then I go here, I say if node size that if node size yeah, then separation is, oh yeah, okay, I can do this within one line, by the way. Const separation is horizontal for reason. Oh, I think it's written like this. Okay. And it's just node dot AABB size. Is it? Yeah. Okay. And this should be bigger. Okay. So if this is bigger or equal, then we take it as horizontal division. And now here, okay. Const is right. So const is a variable is right child is equal to true by nature, I mean by definition, and then if center of a new node. There's the right and left. What should I take for top and bottom? I will take, okay, top and right sides are in child right, but and left side in child left. I think there is a better way to explain this thing here, but for now it should be okay. Maybe I can just rename this from child right and left to something else. To what though? Top right, it could be TR. Bottom left, bottom or left, and top or right, I guess. TR, top or right. BL, bottom or left. Okay, very good. TR, bottom left. Okay, now here is it top right child. So one is for horizontal and one is for like which one this center belongs to. So if is horizontal, is TR is, yep, and else okay, we get the center, we compare it to the center of this node, which is the parent node. So I think I should make this clear that this is a parent node for readability. Okay. Okay, very good. So we have now is horizontal. First we check this, if this is horizontal, is top right child, top or right child, or left or bottom child. We can do this comparison. Okay. And then when we do that now, okay, I think I have to put why did I do this? No, I have to do a nested thing here. Okay. Yeah, we have to do a nested thing. Okay. Else. Okay. Now what? No, no, we don't need the. Okay. It was good. It was good. Now here, if it is top right child, first if if okay, here I would put top right node. This is bottom left node. Oh, this is crazy. Okay, that you just call the insert function on any one of them. You do that. And then else top right cater create tree node. Else bottom left node. Exactly the same thing. Okay, so this can be a function called then Okay. I would call this, I mean, it should be fn create node, and then it has vh. Why does it have bvh? I don't know. How do we do the create node? So the create node has to have some allocator. Some allocator. I mean, allocator is not needed again because there is bvh, right? Mm. Yeah, okay. And it needs a rectangle. And we don't need to return that even. Parents. That's root. Oh, okay, I see. This is root. Alright. Yeah, we create a tree node there in the roots. Right? No. Okay, I'm getting completely confused here. It's been some time I didn't do this, so I don't remember how exactly we should proceed here. Hmm. Okay. Parent node. This is a nullable tree node, right? Alright, no. And then okay, Yeah, that's it. Okay, this now is better. It's just that there's something here missing. So there is no root anymore here. If the parent is null, then we have to do try BVH allocator create tree node there. Yes, that's correct. Or we can just say create node, and then here I will send node free node to nullable free node. Okay, and then node is allocator this and this. Okay, now we can remove that. Parent is equal to try bvh dot create node vect. Okay, here I have to say bottom left try create node parent node dot is it returning anything? No. So it's a void, and this is we send the parent inside this. And here try create node parent node dot child bottom left. Right, this is too long. I can make this function even smaller. I don't need to make this complicated. If this, then it is horizontal, else vertical. And then if it's horizontal, if this, If it's vertical, okay. And then, okay, I need tall. Okay, what am I doing? Okay, so we come here, this is horizontal, and then we go here, this is vertical, horizontal, this is right side, right? So we say top right node, insert rect. Well, what is the top right node? It's parent node dot child tr. Okay, node child tr. And then here I'm gonna put node. Okay, else there, and then try create top right angle. Okay, I don't like nested ifs, so this is horizontal, this top right, this is bottom left. Then you have to do that. Oh, this is too many of them. So can I make this much less? Yes, I can put the condition saying that if it's bigger here, okay, I will put this here. Again, I have to define my variable. Const oh, access is a really good name, by the way. Okay, and then const top right is top right. Oh, actually, I can just put this is horizontal. Axis is horizontal, and or is not horizontal, and it's like this. Okay, very good. So if this is top right, maybe it's easier. Okay, so if it's horizontal, if this is the size 0 is bigger, then the cutting is horizontal, the clipping is horizontal. Is top right, it's top right if it is horizontal and the center 0 is bigger than parent node center. And here it's this one. So in both of these conditions, we have to go top right, top right, tr. We can remove all of these conditions. And then we say, okay, is top right, do this, else do the other one. And then here, I don't think we care about the rest of them. Okay, let's try. It is horizontal, is top right. If it's top right, you have to check if it's null. If it's not null, you call the insert again with this rectangle. If it's not null, you create the node. If it's null, you create the node. Similar thing happens. Here I can just do return, by the way, and yeah. And then here, insert or return. Very good. Okay, so I have a center. I have a parent node is horizontal, parent node side. Okay. Then if it's top right, we do that or this. I think there might be a better and easier way to write this even. But for now, so wherever we call a function, call insert, we have to return there, and then this is going to just automatically do it. Okay. Very good. So that should be insert. There should be the init function. Oh, this is a public one again. And then the init. VH, and then allocator. So how do we do this? We have to go okay, if bvh.root, indeed. But here we dereference. I don't even know if I can use this formulation, by the way. Root destroy or root the things. Okay, okay. And then here I will have to find in types, or was it types? No, in here. Ooh, I'm doing a struct here inside the struct. So okay, I guess I have to do this. Okay. Now here I have to do public function deinit. There is node. It's a nullable. No, it's not. It's free node. And then there's the allocator, top right, .init, bottom left, .init, and then we do the display. Very good. Okay. Okay. Now I want to be able to do this. Oh no, this is not good. Yeah, I'm doing binary tree. This is not a binary tree. This is a bounding volume hierarchy. Oops. It's a bounding volume hierarchy. It's not a binary tree. So almost everything is correct, I guess. It's just that we have leaf nodes and we have branch nodes, right? Leaf nodes can have top right or bottom left, and the branch nodes can, branch nodes can be like that, and then there is a leaf node that is like always a rectangle. And you don't, oh no, you can have a rectangle. Sorry, you can have a rectangle, but it's just that you can have a rectangle, right? Okay, yeah, that's correct. Even in a bounding volume hierarchy, we have a rectangle. It's just that this rectangle is not real. It's more like a region where my platform rectangle could be in. So, okay, so the logic should be different, but the tree node is okay because we need a rectangle anyway for that. To do that, by the way, this is our map. This is gonna be used in the map. So instead of storing all the platforms in one list or array, I will have to use this kind of data structure to store all my platforms in it. So yeah, so here I have to just write down here to remember for myself. Area, this array is going to be replaced with a BVH structure. Okay. There is that, which means that this is a platform, and here the leaves are platforms, and the platform can have many things, like it can have texture, it can have many things, but then my branches are always rectangles. I don't care about texture. I don't care about anything else when I have branches. So I will have to have two structs. Public const. This would be a branch node, and then a branch can have two leaves, and for leaves I will have const leaf node. Leaf node is just branch node is, ooh, this is okay, this is a union, right? This is a union, and then there is an enum. Okay, it's a union. Node type. It's an enum. Leaf branch, right? And then here I would put the node type, and for leaf it is leaf branch, branch. So leaf is t dot platform, and so the branch is nullable branch nodes, right? So it could be a leaf, basically it could be a platform. And then each branch node has no, it's a branch node. Mm, the branch node is a union, branch node or a leaf, right? And then the branch node has constant branch node. Oh, I can just here. This is a branch node. Branch node can have wow, this is crazy. Okay, I can make that every node has a rectangle for its shape. And it can have two children. Or it could just be a leaf, basically. And if there's a rectangle, this is the AABB. It's showing now. Very good. Okay, does this work though? I don't know. There's a platform, there's the branch node type. So the root function would be the tree node, and then at the beginning we can put a branch node and put it null. It's so weird though, kind of twisted, but it works, I think. There's no easier way, no? I could make it all in one struct, by the way. To have AABB and then there's a platform. And the platform could be a nullable pointer to platform. There could be 3 pointers and 1 rectangle. Or a union of a rectangle or platform. So it would be either AABB or platform. There would be node type. That would be a union. Union. Okay, I can also do this one. I feel like this is much better. So this would be either a platform. Should I do nullable? Can just contain the platform or rectangle. T dot rect. So it's either platform or rectangle. That's a node type. And then here, that would be tree node. It's either children or here. That would be type. Nullable node type. Okay. Tree node. Remove it. I think this is easier to handle now. So we are either, oh no, why node type? It's nullable node type. We have to see if it's null or not. Could have nothing. And then here there's the node.child tr with the init this, with the init the allocator, and then we just destroy allocator to destroy the type also. Okay. And then the node itself. Okay, very good. This seems more easier for me to follow. So each tree node either have children if it's a branch. If it's a branch, then the type should be either one of the rectangle or okay. So it's either a rectangle or a platform. We don't have to put it null. Yeah, okay, very good. So by definition, we have to value this somehow. And then, yeah, this should work. Okay. And then we come here. This is the structure, VVH structure. I have a root, which is a tree node. I have allocator. What I do, I create this a pointer to this structure, and then I send it by init. I initialize the whole thing. Very good. It's null at the beginning. So then and then there is the init. Very good. It still works, this thing. So now we go to insert. So here insert is insert rectangle. So first part of insert is a search. So we have to search through all the branches of the tree to find the better location for the location of this rectangle to be added. And this is not good, so this is not working. So I would have to send, like I would have to insert with bvh.root, and I don't want to have access to bvh.root outside. I don't want to do that because it's not, I think it's not good. We can do insert bvh and then we have a platform. Okay, so we are going to insert a platform to this tree structure. So the first thing is to have okay, none of this will work if I don't have a shape for this thing. There should be map size. It's a vec2 and then this would be root would be create platform, create rect, I guess. No, this is a root. We can just do, I mean, I might have to make those functions, but right now. So child tr is no. Okay, and type would be, it's not enumerator. I have to, it's a union, so I have to put this here. It's a rectangle, so rectangle has position. and position will be 0, 0, and size will be map size. Okay, so the root is this thing. Map shape t dot rect. And here type is, oh no, it's not here. So it's leaf, and it's equal to map shape. Okay. The union, either leaf or branch. Okay. So this is good. No, this is not a leaf, by the way. Leaf is a platform. This would be branch. Right? Did I do it right? Yes. Branch is a rectangle. Very good. Okay. Sorry. Now that we have this, we have the insert direct, insert. So now insert have to go from this root that we have and just find the location for this platform. So to do that, we first get const root avh.root, and then const center is equal to sorry, what is this? Const center, it is platform dot shape dot center. Okay. Now we have the center. Is horizontal. I mean, it's not needed. I think the first division is always a horizontal division. But, you know, I don't know. I guess I might use this algorithm for another type of game where it could be non-horizontal thing in the beginning. So I'm gonna have to say root dot type the branch. Okay, so I cannot access that right there, so I have to say var const root type root that type var is horizontal would be switch root dot type dot root dot type. Okay, I forgot I can use switch to return values. If it's a branch, this thing okay. If it's a branch, yeah. If it's a branch, you just return branch that size is bigger than this size. If it's a leaf, oh no, okay, this doesn't work. Yeah, this doesn't work. I have to rewrite this again. So the child is either branch or leaf. We should make the whole thing a union, I guess. Yeah, I will continue doing this. It's been now 2 hours, I think. I'm live. We'll continue doing this when I come back in our 2 or 3 hours. Thank you all of you for watching. Let me just update the code in GitHub. Don't forget to subscribe and like the video if you haven't done so already. It would help to support our channel a lot. So here I will update making the BVH system working. Okay, when I come back, I will continue writing the code. For this, it will be 2 or 3 hours later. Yeah. And thank you for watching. I will try to figure out a way to, maybe I can do a private stream and then see how is the result of the sound and stuff. And then I will see if I can put the music. Yeah. See you. Take care. Have a good day or night. Bye bye.